Hi everybody, this is part 2 of my general overview of Geometry A topics. At the end of my last video, I gave some inaccurate information about how to answer number 10. So I'd like to start this video with the correct way to do this. So here we go. At the end of my last video, just to recap, what I said was that the exterior angle theorem could be used to answer this, but that's actually inaccurate. The correct way to do this would be to use the vertical angle theorem, which says that these two are congruent. Therefore, I can call this 2x plus 13. And then to also use the triangle angle sum theorem, which says that in any triangle, the sum of the angles is 180. So applying that, I would get 2x plus 13 minus 11 plus 6x plus 90 all equals 180. Now I just need to combine like terms and continue to solve this, but this would be 8x, 13 take away 11 is 2, plus 90 is 92, and then subtracting 92 from 180 gives me 88. So now 8x is equal to 88, which means that x is 11, and that would be the correct way to answer this question. So I apologize for the confusion for my last video on this. Okay, let's go ahead and move on. Number 11. In number 11, we have to find the measure of this angle, which we currently don't know. This is a quadrilateral, and what that means is that all the angles inside add up to equal 360 degrees. So I'm going to take that idea and create an equation from it, and that would be 85 plus 120 plus 75 plus my missing angle, which you can use a variable for if you want. All this equals 360. Now I just need to combine my terms and solve this thing. So this would be 120 plus, let's see, 85 plus 75 would be 160 plus my question mark is equal to 360. So therefore, my question mark plus 280 is equal to 360. And by the subtraction property of equality, my angle is 80 degrees. And that makes sense because when you look at this angle right here, you know, it's close to being 90. And so 80 degrees does make sense according to how this thing does look. Let's go ahead and move on. Numbers 12 and 13 are asking for whether or not there's enough information to state that the two triangles are congruent. And just a little tip here. If a question ever says, determine if something is this, or blank, 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 if possible, what that means is that there's a possibility that it will not be possible, or that it cannot be determined. And so you want to keep an open mind for that to be one of your possible answers to the question. Number 12, we have to look at the markings, and what I see is that I have an angle, I have a side marked, and I have another angle. And the corresponding parts do show an angle, a side, and an angle. So this is definitely congruence by the ASA, or angle side angle theorem. Number 13, however, is a little different. Although I do have a side here, and I do have an angle here, this angle here is not the corresponding angle to this one. You know, it's like a circle and a square. They just do not align with each other. And for that reason, there is not enough information to state that these two triangles are congruent. Now, someone could argue, well, by the reflexive property, this shared side makes this SAS. But again, these two angles, one circled and one in a square, are not actually corresponding angles. And for that reason, we cannot say SAS for this, nor can we use anything else. And so the answer to this question is that there is simply not enough information. And so that's what we write, not enough info. Moving on, number 14. Okay, number 14, let's see what we have. In this one, we have an angle, and we have another angle, and then we have the shared side over here, which is not marked, but because we know it's a shared side, we can go ahead and mark it ourselves. This is angle, angle, side. Now, if you're wondering, well, hang on, in number 13, you were saying that the angles were not corresponding. How do you know that they are over here? Well, all you have to do is look at their positions, and you can see this angle does indeed correspond to this angle. Okay, by the positions that they're in, by the way that they look, you can see that this angle does correspond indeed with this angle there. Okay, because of their positions, because of the way the angles are. So this is indeed angle, angle, side, angle, angle, side from both ends. All right, number 15. This one's pretty straightforward. Almost everything has been marked for you, but we have to mark something ourselves. So we have a side. Now this over here and this over here are vertical angles. So by definition, they are automatically congruent to each other. So I'm going to go ahead and insert my A right there. So side, angle, and then we have another side right there. And you want to check for corresponding parts. So this corresponding part and this one do match up, and I'll just mark them with subscripts. This is subscript 2, corresponds with that subscript 2 right there. So this is indeed SAS, and then you have your congruent angles there anyway, so it's definitely SAS. Okay, number 16. Here we have to solve for x. This is the the external angle theorem. And I know that because, unlike my mistake before, this side of the triangle is extended outward beyond the triangle's vertex. And so for that reason, you create one single angle that is outside or on the exterior of the triangle. And so we have an exterior angle of 109. So what we do is we apply this theorem, which says that an exterior angle of a triangle is simply equal to the sum of the two remote interior angles. And by remote, I simply mean the two angles that are farthest away from the one outside. So I'm going to go ahead and set up my equation to say that. And it will be 190 degrees is equal to 7x plus 14 plus the other angle, which is 4x plus 7. So this is 190 degrees is equal to, and then we have to combine like terms. So this would be 11x plus 21. And then you want to go ahead and subtract that 21 from both sides. So we have 11x here. And that would be 88 degrees. And that means that x is equal to 8. Okay. So again, x is equal to 8, not the value of the angle, just the value of x. That will help you get the value of the angle. If you were to plug it in there, plug this in there, you would learn the actual measurement of angle E and the measurement of angle D. Okay, let's move on. Number 17. This is the segment addition postulate, and the way pardon me, the way I know that is because I have a segment that is divided into two smaller segments, and I'm given the entire length of this, which is here in blue. And so what I can say is that this segment added to the other one is simply equal to the entire thing, which is FH. Now, fortunately, I'm given information that I can substitute into this model equation, and that is that I know FG, which is right here, I know that is 6. So I'm simply going to make FG equal to 6. I also know that GH is 2x plus 23. That's this one here. So I'll make this equal to 2x plus 23. And then FH is given to me as x plus 20. So this now becomes x plus 20. One caution here. You want to be careful not to assume that this is a midpoint. It's a very common mistake. It looks like it's in the middle. It looks like a midpoint, but just because it looks like it is does not necessarily mean that it actually is. So we're going to approach this in a slightly different way using the segment addition postulate. And once we figure out the value of x, we can plug it in, and if we get 6 for this, then we know G is indeed the midpoint. All right, let's get back to this. So now what I have is this equation that I can solve. So I combine my terms. So 6 plus 23 is 29. So 2x plus 29 equals x plus 20. Now, I'm going to do two things at once. I'm going to move the x to the other side, and I'm going to move the 29 to the other side, okay? Just to save time and space. So this would give me x is equal to -9, and that would be my answer. And if I were to go back over here and plug in -9, way back over there, then what we would get is this. We would get that GH is equal to 2 times -9 plus 23. So that's -18 plus 23. And that would be 5. Okay, now let's take a moment and think about that. This is 5. This one is 6. And some of you might have assumed that point G was in the middle or the midpoint, but you can see numerically they are not equivalent. So that means that G is indeed not the midpoint. So just to reinforce that message earlier, please be careful with that. Number 18. Find the distance and the midpoint between the pair of points. All right. This is a question that takes 2 parts, and I think what I'm going to do is actually approach this question in my next video because I am running out of time. And so I'll pick it up with number 18 and go on from there. Anyway, I hope this video did help. Please leave a comment, and as always, thanks for watching. Bye-bye.